Hello and welcome to the solutions video for our March 10th assessments. Just fill in our name here and we will start running through this batch. Just take a moment to load. Again, here is our formula sheet for the rest of the course. Now, the slope-intercept, or the slope-point form of the equation of the line shown could be. So remember, slope-point form is where you have your y minus y1 equals slope times x minus x1. It is this form right here. So if we look at these, we've got combinations of 5s and 7s. They're positive 5 and positive 7. If we go to the point 5, 7, well, that's on the line. If we go to negative 5, negative 7, it's not. So we need 5, 7. The minus signs are built into the equation. So it's got to be an x minus 5 and a y minus 7. Which seems to be a problem here because we don't have the correct answer listed because we have the wrong slope on this point. If we actually have that x minus 5, if we check x, no, here it is. If we do x minus 7, yes, when x is negative 7, y is negative 5. That's the point that works. So that puts us at D. I was looking over here. I need to be looking down here. That was the confusion. So yes, when x is negative 7, y is negative 5, and when you subtract, you change the signs, and this has a slope of positive 1. So next, the equation y equals negative 3 over 2x minus 1/3 can be written in this form when with the greatest common factors removed. So, we have, let's take a look. We had y, sorry, when my hand hits it, it zooms. So y equals a negative 3 over 2x, I think it was minus 1/3. All right. So the first thing we have to do is clear our denominators. If we don't immediately see that the least common multiple of all the denominators is 6, we just start with the biggest one. Multiply everything by 3. Again, if you see that it's 6, you could start multiplying by 6 in your first step and be done. For now, I'm just multiplying everything by 3. This denominator is gone. We multiplied it by the largest visible denominator and simplified. We still have a denominator left. We multiply by our remaining denominator, 2. We end up with a 6y equals a negative 9x minus 2, because the 2's canceled here. Everything else doubles, because that's the only denominator of 2. Now, the form we're looking for is with everything on one side of the equation, preferably positive. So that's 9x when we move this over by adding 9x to both sides. We do that to get the sign positive, so our 6y doesn't have to change. Now we add 2 to both sides. It cancels on the right and appears on the left. So we get 962 as our solution. 962. So moving on to our next equation. Given that the slope of a line is negative 3 over 5 and the y-intercept is 4, the equation in general form is, well, here's our slope and y-intercept. So with the slope and y-intercept, our slope was a negative 3 over 5, and our y-intercept is 4. So put it in slope-intercept form. And now we are asked for standard form, or general form. All right. So we're going to multiply everything by 5 to get rid of our denominator. 5y. We cancel the denominator here. That's the whole point to multiplying by it. And that's 20. If we add 3x to both sides, it'll cancel on the right and it shows up on the same side as the y. And then subtract 20 from both sides. Then we end up with a 3x plus 5y minus 20 equals 0, which is C. Going on, number 3 here. The slope point equation of a line passing through these points. Well, our change in y is 35. Our change in x is 35. So we have a positive 1 for the slope. That narrows it down to A or C. And we have y minus y1, or x minus x1 and y minus y1. So we're subtracting both the 15 and the 18. Notice D, we are adding. So algebraically determine the x-intercept. So we have 1x minus 4y equals 18. Now the question says algebraically determine, but it's also numeric response. So on a numeric response diploma where you hand in the bubble sheet and your question booklet gets mulched before anyone even runs your bubble sheet through a Scantron, you can do it any way you want. They do not mark process on multiple choice and numeric response on the diploma exam. So we're looking for the x-intercept. That's what happens when y is 0. So if y is 0, we have 1x equals 18. So then x equals 18. If our coefficient of x wasn't 1, and I think it is because it's randomly generated, we'd have to divide by that. So if we had a 2x here, then our x would be 9. Either way, we are setting y to 0 and isolating x to find our x-intercept. That is how we find the x-intercept of absolutely anything ever. To find our x-intercept, we always let y equal 0. To find our y-intercept, we always let x equal 0. That's just the way it works. Answer key agrees. So far, so good. So the equation of a line that passes through these points in point-slope form. So the first thing we need to do is find our slope. So let's take a look. Our 2 points are negative 3, 9, and 3, negative 3. So negative 3, 9, and 3, negative 3. Doesn't matter which we decide is 1 and 2. We can call them x1 and y1 here. x2, y2 here. If we do it that way, our slope is negative 3 minus 9 over 3 minus negative 3. That's a negative 12 over 6, which is negative 2. Had we arbitrarily chosen to do it the other way around, we'd have 9 minus negative 3 over negative 3 minus 3. That would be a positive 12 over negative 6, still a negative 2. So having the points the other way around, all that does is flip the signs of both the numerator and the denominator, which cancels everything out. Regardless, the important thing is that our slope is negative 2. Now that we have that information, we can pick either point. I'm going to, and say it's y minus y1. Here I pick negative 3, 9, slope, and then in brackets x minus x1. That is one of our possible answers. Had we chosen the other point, we'd have these. And that freedom to select a point is why I will always have these as written response questions. So once you've got it done, then yeah, I will check. You'd have to have the -2 as your slope, and then you can pick any point that's on that line. You have a few options, although these would be the most popular two, since those are the points that were given. So our next, from the graph below, an equation can be created in the form y equals mx plus b. So now we need the values of m and b. So slope and y-intercept, we check our axes. It is 1 point per line. So this is a clear point, and here's our y-intercept. In fact, our y-intercept we could read off right now is 3. So the main thing now is our slope. Well, that's rise over run. Our rise is 1, 2, 3, 4. Our run is 1, 2. 4 divided by 2 is 2. So we have a slope of 2 and a y-intercept of 3. So we're at the equation of a line in slope-intercept form that is parallel to this line and goes through the point 0, -7. Well, here x is 0. That tells us this is the y-intercept. And if it's parallel, the slopes are going to be the same. So it's y equals 3 over 8x with a y-intercept of -7. So I will just quickly score these written response to verify the answer key. All right, answer key checks out. All right. Now we need surface area and volume of this cone. Now, the right cone, our surface area is pi r squared and pi rs, where s is the square root of r squared plus h squared. That's right here on our formula sheet. So this is a matter of substitution where our radius is 7, our height is 10, and they actually give us a slant height of 12.21. They don't actually need to give us that slant height because we have our r and we have our h. In fact, if we just do the square root of 7 squared plus 10 squared, it's the square root of 149, which is 12.206555562. So the formula that we have will be more accurate. In any event, this is just plugging it into the calculator. So we have a pi, and then r is 7. So pi r squared is pi times 7 squared. And if we go next, pi times r, which is 7, times h, which is, oh, we don't want just h, we want the square root of h squared. So, okay, pi times 7 squared plus pi times 7. If we use the 12.21 we're given to the nearest hundredth, it's 422.45. If instead of using the 12.21, we actually do our exact calculation, or the more exact, because we're running through a calculator anyway. But if instead of the 12.21, we do 7 squared plus 10 squared, that works out as 422.37. So I'm just going to check this answer key before going on, because it would always be nice to make sure that everything works out. So I'm going to have to double check that and make sure everything adds up. And I think right now that question is worth a few more points than I anticipated. I'm going to have to double check that. So in any event, checking the answer key, yeah, it does have tolerance. It's looking for the 422.45, but entering the 37, it is marked as correct. So that's not a problem. Although it does seem that they're out of 2 marks each, which is a little more than we wanted. So the volume of the 3D object. The volume rounded to the nearest hundredth. The volume equation is pi r squared h over 3. So if we do pi times 7 squared times 10 over 3 to the nearest hundredth, it's 513.13. So now we have a sphere of radius 9. Well, the surface area of a sphere is 4 pi r squared. So 4 times pi times r squared, or 81. It's 324 pi exactly. To the nearest hundredth, it's 1017.88. And the volume, you can actually multiply by another 9 over 3. It's 4/3 pi r cubed, which is a 972 pi, or a 3053.63 for our volume. So those check out. And our last question in measurement 3, a cylinder has a given diameter and is 8.4 centimeters high. Keyword here is diameter. The equations are given in terms of the radius, so we're going to have to divide this by 2 to work with it. So the volume is pi r squared h. R is 5.8 divided by 2, so our radius is 2.9. So pi times 2.9 squared times a height of 8.4 centimeters gives us, to the nearest tenth, 221.9. So I will just double check our answer key here and make the adjustments to the point values. All right, moving on to the next one. We are now into our systems of equations. So in solving the system below by elimination, an equation that shows up when eliminating y. Now notice the two y's are on 2 different sides of the equation. So we have to bring this y across. We'd have a positive y. Now to eliminate y, we'd have to multiply both sides by 6. So with a multiplication by 6, we wouldn't have the 10x. We'd have a 48x plus 2. So we'd have a 50x here. And the 60 would now be positive on this side. Multiply that by 6, it's 360 minus 110. So we'd have a 50x. Okay, I'm going to do this out so it's much easier to see and follow. So our first step is to take our 8x minus 60 minus y, well, minus 60 equals a minus y, I should say. If we add both 60 and y to both sides, we have an 8x plus y equals 60. Now if we're trying to eliminate y, when our other equation has a minus 6y, the easiest way to do that is to multiply this whole thing by 6. So I have a 48x plus 6y equals 360. Our other equation is 2x minus 6y equals a negative 110. Now we can add the two equations. Had you multiplied by negative 6 and subtract them, then all these would be negative. We'd have the same final result. The 48x plus 2x makes 50x. The y's cancel by design. They're eliminated. That's what elimination is all about. And 360 minus 110 is 250. So, school's outdoor club held a car wash to raise money for a camping trip. They washed cars for $6 and vans for $8. They washed 51 vehicles and made 340. How many cars did they wash? So there's cars and there's vans. So we know cars plus vans is 51. Now they also charged $6 per car and $8 per van. So 6 cars plus 8 vans. And they made 340. That is supposed to be a 3. So how can we do this? We could do substitution. We just did an example by elimination. Let's do this by substitution. So let's take our first equation. We are looking to find cars. So I'm going to start by isolating vans. Seems a little counterintuitive, but we don't need to know the number of vans. We only need to know the number of cars. I would recommend finding both and substituting in as a way to check your work. Make sure that whatever number you have for cars and vans works in both equations. So that's the way I'll do it here. But technically speaking, we don't have to. And for isolating v first, when we substitute this in, we'll have an expression for the number of cars, and when we solve for the number of cars, we'll technically be done. As I said, we'll have our answer if we've done everything correctly, but it's always good to check your work, because with systems of linear equations, you can do that. You can substitute your answer back into the original questions, the two equations you have, and make sure it works. So we replace v with this expression for v. Now, you could have also multiplied everything by a negative 8. I think I'll do that as well to show both ways. 8 times 51 is 408 minus 8 cars is 340. If we start by collecting like terms for cars, we get a negative 2 cars. Move our 408 across by subtracting 408 from both sides. And we get negative 2 cars equals negative 68. So we should have 34 cars, which would make 17 vans. So if we do 34 times 6 plus 17 times 8, that does make $340. So we can substitute this one in to check. Doing it the other way, if we have 6 cars plus 8 vans equals 340, multiplying the cars plus vans equals 51. If we multiply this by 8, sorry, I wrote 6, but if we multiply it by 8, we'd have 8 cars plus 8 vans, and 8 times 51 is 408. Now we can subtract the equation on the bottom from the equation on the top. We still get our minus 2 cars. Our vans are eliminated. That's by design. Again, we eliminate the v's. We're left just with the cars we're looking for. And we still have a negative 68, which is a step we had in the previous one. We quickly get to 34 cars. So multiple ways to get to that answer. We have 34 cars, which also means 17 mans, but they're not asking for that. All right, a friend sent you the following puzzle. Because people will run screaming from linear relations when they show up in Math 10, but if they see this in social media, they go, hey, I can do that. So we have 2 watermelons plus an ice cream cone equals 11. A watermelon plus 2 ice cream cones is 13. So clearly this watermelon, or this ice cream cone, is worth 2 more than a watermelon, because replacing a watermelon with an ice cream cone increases the value by 2. So that's like saying our top row is 3 watermelons plus 2 equals 11, or 3 watermelons equals 9. So a watermelon is 3. An ice cream cone must be 5. Okay. We could actually do this if we write it algebraically. We have 2 watermelons plus a cone is 11. And 1 watermelon plus 2 cones is 13. So if we were to isolate our watermelon in the second one, substitute it into the first, so we have 26 minus 4c plus c is 11. So 26 minus 3 cones is 11. So that gives us 15 equals 3 cones. That's supposed to be a C. That's the problem with using a web-based board or web-based whiteboard. So our cones are 5. And when we substitute that in above, we get our watermelons are 3. Now here, a cone minus 2 sandals is 3. So a cone minus 2 sandals or flip-flops is worth 3. That means a cone minus 3 is worth 2 sandals. So a sandal is a cone minus 3 over 2. 5 minus 3 over 2. 2 over 2 is 1. So these sandals are worth 1. So 1 plus 3 is 4, plus 2 cones here, so that's 10. 4 plus 10 is 14. So we get all the internet points for that. Now the perimeter of a rectangle is 176 centimeters. Twice the width is 13 less than the length. So which pair of equations will determine the length and width? So the perimeter is 176. So we have a 2L plus 2W equals 176. That immediately gets us to A or C. Let's translate our second sentence into algebra. Twice the width is 13 less than the length. So we have twice the width is, any conjugation of the verb to be becomes our equal sign, 13 less than the length. That's length minus 13. We don't have any minus signs. So we can add 13 to both sides. That makes everything positive, and that is a match for C. So it's not standard form because the variables are on opposite sides of the equation. However, that does make solution by substitution fairly easy to do. We have an expression for L. We can plug it in here and go. But we don't need to solve it. We just need to recognize the correct setup. Now, the system here, 4x minus 3y equals 8, and 12x plus my equals n, has an infinite number of solutions if. Well, we have the numbers here. What matters is the interpretation. They have an infinite number of solutions if they are exactly the same line and line up on top of each other. We can get that by taking 4 and multiplying by 3 to get 12. So if we multiply the entire first equation by 3, then we'd have the same equation. That makes m a -9. Only one of these has -9 as an option. N would be 3 times 8, which is 24. But that is our solution. Okay. So we do have one question that's currently being marked incorrectly because on this one about these cars, the answer key for some reason is keyed for the price of washing a car and not the actual number of cars washed. So we may still see that one wrong answer in the end, but I've just corrected it for the assessments you guys will be doing. All right, jumping ahead to the next undone question. Evaluate the following expression. The cube root of 8 squared plus 4 to the -1. Now here, whether we do the cube root of 8 or the squared is up to us. That's the same as the expression or the exponent 2/3. We can run this or through our calculator pretty much exactly as written. 8 squared is 64. Cube root of 64 is 4. Plus 1 over 4 is 16 over 4 plus 1 over 4. Now in this one, only 2 of these students simplified correctly. We need to figure out which 2. So looking at student 1, we have a -7 times 4. That does make a -28. X to the 5 times x to the 3 is x to the 8 because we're adding the exponents. Y to the 1 and y to the 8. This works. Student number 1 is correct. Now 3 to the 4 is 81, and x to the 7 times 4, that is x to the 21. Student 3 and 4 should be done incorrectly. We'll double check as a way of checking our first 2 answers. The 6 over 3 does reduce to 2, but x to the 8 over x squared should be x to the 6th. We do 8 minus 2, not 8 divided by 2. Similarly, we have 2 bases here. We should be adding these exponents for student 4, so the 5 plus 6 makes 11, not 30. Now here we want to rate this power with positive exponents. Well, first off, 12 over 15, there's a common factor of 3. That reduces to 4 over 5. So we can have option C. Now p cubed over p, that's 3 p's on top, 1 on the bottom, 1 cancels from each end. We're left with 2 p's on top. So p squared, that's either A or D. We're narrowing it down again. Q's, we have q to the -7 up top. That's the same as q to the +7 in the bottom. And then q to the 6 times q to the 7 is q to the 13 because we're adding them. So D is the one we have left. For something like this, we can turn our annotations on and say it can't be this one. So as we are doing our multiple choice elimination, we don't have to try to remember. We can put our X's next to it and say, yeah, it's not C, it's not B. Number 12, as we go forward, it's slowly loading here. There. When simplifying, what is the exponent on x? Well, we start with x to the 5th. There's a 3 on the outside. And because there's exponent raised to 2 and exponent, we're multiplying. So our exponent is 15. Now here we're going to use the following information. We have to solve for p, q, r, and s. So p, these are both base 4. We just have to remember this is a multiplication. So 2p equals 16. May not be super easy to read. I'll try to zoom in for these. If 2p equals 16, then p equals 8. For q, so we're going down, not across, 2 to the q times 2 to the q is 2 to the 2q. So 2q equals 16. Q is also 8. Now 8 to the 5 over 8 to the r equals 8 to the 3. So 5 minus r is 3. We have to have subtracted 2 from the 5. And then finally, s times 6 is 1. But how do we get to 1? That's a 0 exponent. So if 6 times s is 0, s is also 0. All right. Reset the zoom and move on to our next question. So several numbers are listed. For each question, choose a number which fits the description. More than one answer may be possible. So which of these is irrational? That's going to be C. Pi is irrational by definition. D is tempting, but we don't have the dot, dot, dot. Now, if it's an integer but not a whole number, the wholes go 0, 1, 2, 3. So 5 is both an integer and a whole number. 12 is an integer but not a whole number. So which of the following is irrational? If we wanted to, we could run each of these through our calculators and see which one comes up with a non-terminating or at least non-repeating decimal. Square root of 144 is 12. Cube root of negative 27 is a negative 3. Square root of 9 over 16 is 3 over 4. So cube root of 16 is irrational. The cube root of 8 is 2. 16 has an extra factor of 2 in it, and the cube root of 2 is irrational. Now this number, which sets of numbers does it belong to? Select all that apply. It is rational. It's got non-terminating or non-repeating decimals or no visible decimals at all. It's an integer because it's negative. It is not natural. That's 1, 2, 3. It's not whole because just like the naturals, they don't allow negatives. And everything is either rational or irrational. It can never be both. Irrational would have a non-terminating, non-repeating representation. And here, negative 52 over negative 53. It is not an integer because we cannot write it as a fraction over 1. That also means it's neither whole nor rational or nor natural. So it's either rational or irrational. This one is rational because it's written as the ratio of two integers. That's the very definition of a rational number. So expanded and simplified form of this. All right, we have a 7x minus 8y. So 7x minus 8y minus x plus 5y and then minus a 3x minus 2y. Before I start collecting any like terms, I want to get rid of these brackets. I do that by distributing that negative sign through the brackets. 7x minus 8y. Bring the negative through. That's a negative 8, or negative x, a minus 5y, negative 3x, plus 2y. Now we're going to collect our like terms. How many x's do we have? 7 minus 1 is 6, minus 3 is 3. So we've got our 7, our minus 1, and our minus 3. I like crossing them out when they get long, so when we're done, if we have anything not crossed out, we could check to see if we missed anything. Now, a negative 8 minus 5, we could even do it in 2 steps if we want. So then we have our minus 13y, and now we have 3x minus 11y. When you combine our negative 13 and 2. And there's 3x minus 11y right there. Now, when this expression is expanded and simplified, the numerical coefficient of the x squared term is. This is one that will actually be easier using the box method. So we have a trinomial here. And a binomial out front. So let's go back to our whiteboard marker. I think it was a 1x plus 7. And we had 1x squared plus 4x minus 9. Might have, yeah, I have an extra box here. So all we care about right now is the x squared term. Let me just get rid of this extra column because I miscounted. That should not be here. So if all we care about is the x squared terms, we're going to have x squared times 7 to make a 7x squared, and x times 4x to make a 4x squared. This would be x cubed. These would be linear in x. That would be a constant. So these are the only two we care about. 7 plus 4 is 11. That's where the box method is more convenient for this type of problem, because we can more easily pull out just that one coefficient we need. Now here we expand and simplify. Well, a negative 1 times a negative 4 is a positive 4. So if we go back to our annotations with a pen, we want that one. Anything with a negative 4 we can cross off. That annotation we want to keep. Yeah, we can cross it off. We can go right through here. Oh, that's the eraser. So yeah, we can say that one's gone. That one's gone. So the question now is our cross term a negative 5 or a negative 3? Well, p times negative 4 is a negative 4 and a negative 1. So those are going to combine to make a negative 5. That's b. Now, x minus 6 squared. C is a trap. I would like to stick Admiral Akbar in here right now. It's a trap. Remember, this x minus 6 squared is saying x minus 6 times x minus 6. So that's x times x gives us the x squared we have everywhere. A negative 6x and another negative 6x gives us a negative 12x in the middle. And then the negative 6 times negative 6 is the positive 36. Don't miss that negative 12x cross term. It's easily the most common mistake. Now finally, we're multiplying these together. This will be easier because we have 3 of them. We'll take 2, multiply them out, and then multiply it by the other 2. So I'm going to plan my box a little bit better this time. I'm going to start with our polynomials. I'm going to do the binomials first. 3x plus 4. And the other is a 4x minus 2. Do our box like this. Our lines like so. Okay, and when we multiply them out, we get a 12x squared minus 6x, a 16x, and a minus 8. So 12x squared minus 6 plus 16 is a plus 10x minus 8. So box method again. 12x squared, 10x minus 8. This time our only other number is 2x. So with this, I'm actually only going to draw those lines. I'm going to switch to a different color pen here for the answer. 2x times 12x squared is 24x cubed. 2x times 10 is a 20x squared. And then 2x minus 8, negative 16x. So our A was 24. I have to check the signs here because it's got a negative B and a positive C. And we have it the other way around. But we don't have space for the negative sign, so we should be able to sort that out. It does mean I need to go back and change the format of that in the question. But our answer key checks out again with these answers. Okay, so you'll have either the plus or minus sign on that question when you see it. Now here we are factoring. We have lots of factoring. This looks scary, but it's really just 5 instances of factoring. So what two numbers multiply out to make 1? That's going to be our A and C. That could only be 1 in both cases. Now what numbers multiply out to make 8, but add up to make 9? That's got to be 1 and 9. It's the only combination that works. Other factors of 8, 2, and 4 would add up to make 6. And that's not what we get. So I'm just going to check. This does seem ambiguous. A is smaller than C. If we keep that pattern, we should have where A is smaller than D. And I suspect that's where we're going. Yeah, so they do want B is smaller than D. I need to put that in the instructions. All right, so our next batch. This is our difference of perfect squares. Notice the instructions. Negative numbers should be placed later in the equation. Now this is a set that I will be manually marking. Because, yes, it's important to do this, but practically speaking, in terms of the math, it really doesn't matter whether you type the 3x plus 4y before or after the 3x minus 4y. This is what I consider an artificial restriction for the sake of computer scored answers. So I will be manually checking AN5 for everyone who writes it to make sure any missed questions are just that. If you have them the other way around, you will get full credit. I can't code it to do full credit because then you might have -4 for both, which is incorrect, but the computer would score it correctly. Now here, numbers that multiply out to 2 or 44 that are going to add or subtract to make 19. So let's start with this one. A is smaller than C. Well, 2 is prime. So if A is smaller than C, A is 1 and C is 2. There's just no way around that. Now, what are factors of 44 that we can multiply into 2? Well, 44 is 4 times 11. If we have 2 times 4, we get 8. 8 plus 11 is 19. So again, we're checking for the factors here. So our possibility tables, we had the 2x plus 11y, and here I put the 2 first, because that's my instinct, is to put the larger coefficient first. So 11 times 4, I put y's. Are there y's in this one? There are. 11 times 4 is 44. 2 times x is 2. Now when we multiply it out, 2 times 4, right, we have our 2x squared. We have our 44y. But 2 times 4 is 8y. 11 times 1, oh, that's an xy. 11 times 1 is 11 xy, and then 8 plus 11 is our 19 that we're looking for. So 1x goes in the same bracket as 4y, and 2x goes in the same bracket as 11y. Now, 25x squared, that's a perfect square. That's 5x squared. 16y squared is a perfect square. That's 4y squared. So 5 times 4 is 20. If we have 2 of those, we get 40. So this is 5x plus 4y. This is the product of perfect squares pattern that you should recognize. It'll save you a lot of time. We could write these in literally either order because the two factors are identical. They're both 5x plus 4y. Now finally, we multiply out to 21 and multiply out to 4. Now if this was 1 times 21, we'd probably have a massive number in the middle, and we wouldn't be able to make the 10 extra. So this is probably going to be 3 and 7. So how do we get to 21 from 3 and 7? Well, if we go 7 times 4, that's 28, plus 3 makes 31. So A is smaller than C. We're going to have a 3 and a 7. Our 7 has to multiply the 4, which means the 7 and 4 have to be in different sets of brackets. So this is 3x plus 4y. Three x plus 4y times a 7x plus 1y. Don't actually need to write the 1, but that gives us our 21x squared from the 3 times 7. It gives us the 4y squared at the end from the 4y times 1y. And then our 3 times 1 gives us 3xy, and the 4 times 7 gives us 28xy. So we have 21x squared plus 31xy plus 4y squared. So these should check out. I'm just going to take a quick look at our answer key. Make sure we have no surprises in scoring. Okay, no surprises in scoring. Our last set of questions. The graph of a circle is not considered a function because it fails the vertical line test. The vertical line test is what we use to check for functions. If it passes, then it's a function because a vertical line never passes through it more than once. So if we are looking at a circle, x squared plus y squared equals our radius squared. So if we say 25, that gives us a circle of radius 5. And if we have a vertical line anywhere between plus and minus 5, it'll intersect it at 2 points. Actually, x equals 3 would make it a little bit nicer. Then we'd have nice, clean 3, 4, 5 Pythagorean triangles. So that is why a circle is not a function. The set of ordered pairs that represents a function, well, it's going to be one that do not repeat the x values. If we have repeated x with different y, then that is out. So C is out. Now, the set of ordered pairs is a function because outputs can repeat. Well, outputs can repeat is true. It's not a reason why something is a function. So that is not a valid explanation. The set of ordered pairs is a function because each input has a unique output. That is our definition. Each output having a unique input is not a definition of the function. That is backwards. So we need a little bit of a process of elimination here, but it is A. So, waiting for number 19 to load. Here we go. How can you identify a function from a set of ordered pairs? So we check if the inputs and outputs are the same. Outputs don't matter. Each input has exactly one output. That's the definition of a function. Each input can have multiple outputs. That's not a function. It doesn't identify it. It actually eliminates it. And it can be identified if each output is exactly one input. That's backwards too. Which the following best describes a function? Each input has exactly one output. These are fairly similar questions. Finally, how can a function be represented? Well, we can use a graph or a table or an equation. They are all valid. So, two lines have slopes of 12 and a -1/12. What's the relationship between them? Well, they are perpendicular. If they have different slopes at all, no matter what, they will intersect exactly once. The lines are identical. We don't have enough information to make that determination just from the slopes. If the slopes were equal, then we could say they're parallel. We'd have to know the y-intercepts to confirm that they are actually identical. So here we could say the lines are perpendicular because yes, 12 and a -1/12, those are negative reciprocals. That's perpendicular. A line falls every 7 units for every 6 units it runs. Well, slope is rise over run. Change in y over change in x. The change in y is -7. The change in x is 6. That fraction does not reduce. In fact, if numerator and denominator are different by 1, they can never reduce. Because if you take numerator minus denominator, the answer has to be a multiple of the greatest common factor. So, if the difference is 1, the greatest common factor is 1 as well. A vertical line has an undefined slope. That is the technical term. Infinity might be tempting because we're dividing by 0, but it is undefined. That is the proper mathematical term. 0 is a horizontal and 1 is diagonal. So if a line passes through these points, well, what is 22 minus a -13? That's 35. 5 minus 26 is a -21. So if we do 35 over a -21, those are both multiples of 7. So we have to reduce that. That's a -5/3. And a car travels 570 kilometers in 12 hours. 570 divided by 12. Well, that is 47.5 kilometers per hour. But we need to make sure we don't have any decimals. We don't have permission to use decimals. So we express that as 95/2. One hint, if you try 47 point, oh, it is accepting that. It should not accept that decimal. We'll have to check that one. Okay, so what is the domain of a linear function? If a function is neither vertical nor horizontal, so if it's not just y equals or x equals, then both the domain and range are all real numbers. So which accurately describes the domain of the function? Well, it's not always a finite set. We just saw an example where it's all real numbers. The set of all possible inputs, yes, that's the definition of domain. It will not be the same for all functions. I can give you two different circles with no overlap. They will have no points in common. And it's not related to the outputs. That's the range. So how does the concept of domain apply to real-world situations such as measuring time? Well, it would be something about what values of time are allowed. For example, continuously from 0 onwards. Time can definitely be measured in numbers that are not whole numbers. If you measure in minutes instead of seconds, you've automatically introduced fractions, if not decimals. We can't say time is irrelevant. We can put anything in a function, really. Time can be negative. Well, that's not terribly closely related to domain. This is more likely. Technically, you could say, yeah, before the starting point, but it's not the way we usually do it. We have what we call a gauge freedom, which, thanks to Noether's theorem, is why we have conservation of energy. But that's a completely different story. Now, which of the following best summarizes the relationship between domain and range? Domain refers to our inputs, and range refers to our outputs. That is our very definition. Now, domain is always larger than range. Not always. That is nonsense. That might be true for a horizontal line. A vertical line is the other way around. Domain and range are the same. Not in many cases. And range is irrelevant to the function. Well, no, then why would we be talking about it so often? All right, here we go. Our last skill here, RF8. What does the notation f of x represent in function notation? That is the output value of the function. X is our input. F of x is the output, which is the same as y in a lot of cases. The primary purpose is not to confuse students, although that might be what they feel like. It's to represent mathematical functions clearly and concisely. Believe it or not, replacing y with f of x is more clear in a lot of contexts. If you have got 6 different letters in the equation, where 3 are variables and 3 are parameters, function notation lets you list just those 3 variables in the brackets, omit the parameters. So that clearly tells you what's going on, and you don't have to describe it as long as you understand what the notation means. Function notation is where we have that f of x or g of x or h of x or some letter with the input in brackets. Now, given this function, find f of 15. That's where we substitute 15 where the x is. So this is 5 times 15 minus 8. 75 minus 8 is 67. Now find x if f of 90, or f of x is 90. That's the flip side. That's where we're saying 90 is 5x minus 8. We add 8 to both sides. And divide by 5. 98 is not a multiple of 5. So 98 over 5 is fully reduced. So, right, we identified there was the one miskeyed question that I was not able to correct in the live assessment, although I have corrected it for your assessments. That's the one we are missing. So again, if we go to our assessment view, the Schools Outdoor Club, this is the one that they're saying is incorrect. That's because if we check our answer key, Under RF9, it's looking for 6. Question 9 wants 6 as the answer. So again, as I said, the answer key had the price of washing a car, not the number of cars being washed. So that's why it is incorrect in the solutions version, but it is going to be correct in the one that you guys write in class. So, if you have any questions about any of this, don't hesitate to ask.